I'm Alyssa.
I'm Natalie.
And I'm Anne, and today we will be talking to you about the analysis and improvement of the security building at PG&E Diablo Canyon Nuclear Power Plant.
On today's agenda, we will be discussing the background of our project and also the background of PG&E's Diablo Canyon Power Plant. We will discuss the DMAIC process that we use, the define phase, the measure phase, the analyze phase, the improve phase, the control phase, and also our conclusion. So first, we would like to discuss the Diablo Canyon Nuclear Power Plant's background. It is located in Avila Beach, California. It provides low-cost, carbon-free electricity for more than 3 million people because nuclear power plants like Diablo Canyon emit no greenhouse gases during the production of electricity. Diablo Canyon is considered a vital economic engine as it helps to make PG&E the largest private employer in the area. Diablo Canyon is also a good neighbor because they routinely support their surrounding community by making monetary donations to local nonprofit organizations. Additionally, Diablo Canyon takes care of the environment because, like mentioned before, they emit no greenhouse gases during the production of electricity, which contributes to preserving the surrounding ecosystems. Recently, Diablo Canyon Power Plant had designed and built a new security building which assumed the responsibility for performing routine checks to prevent any incidents occurring at the power plant. Such routine checks include the use of metal detectors, X-ray machines, and explosive detectors. This new security building was open for operational use within the last 18 months. Since the new security building's grand opening, Diablo Canyon has experienced its first outage in February and March of 2014. Diablo Canyon experiences these outages periodically. During these times, reactors within the power plant may be shut down for maintenance, repair, and also refueling. Consequently, a large number of temporary outage workers are called in to perform these outage duties. At the beginning of the February-March 2014 outage, it was evident that waiting times to process through the new security building for workers were too excessive for both regular workers and new outage workers alike. In order to accommodate the larger flow of workers processing through the security building, security personnel began taking measures to reduce wait times by implementing changes to the current security process. One of the most notable changes included requiring almost all processing stations to be open inside the security building during peak times of the day, and additional officer personnel to be present to man these stations according to regulations. There were effectively 4 hours observed in each workday that were considered peak times, 5 a.m. to 7 a.m., and 4 p.m. to 6 p.m. Unfortunately, running all processing stations during these peak times is very costly to man, as most of these officers are having to work these shifts on overtime. The outage in February-March 2014 effectively highlighted the weak points in Diablo Canyon's security process. The facility was found to be too short to allow for comfortable moving range at both the check-in and check-out sides of the building. The issue was most prominent when high levels of congestion would occur as workers queued up on the checkout side trying to grab and put back on their personal belongings from the X-ray machine. The building was also found to be too tall, which affected the noise that occurred in the building. For example, on regular days, a maximum of 700 workers are processed every hour, and on outage days, the number doubles to a maximum of 1,400 workers processed every hour. The temporary workers are less familiar with Diablo Canyon's security process, which makes them take longer to go through the process and build up more workers at the end of the checkout. The high volume of people, the security process, and the tallness of the security building created a lot of noise in the new security building, which makes it more difficult for the current 11 officers to communicate with each other and process workers through the building efficiently. A competing problem complicating the congested areas was discovered to be the cycling of storage bins responsible for holding items that pass through the X-ray machine. With their current amount of storage bins, it is necessary to transfer bins from the checkout sides back to the check-in sides. Otherwise, storage bins would run out on the check-in side and effectively stop the security operation, as no one could be processed through the X-ray operation. Currently, Diablo Canyon officers are having to manually push these stacks of storage bins through the congested areas within the facility to return them to their stored location on the check-in side. The final imperative issue needing to be addressed is the ineffective use of signage throughout the security system. Signs did not draw workers' attention and did not aid in effectively directing workers through the process. For convenience, our problem statement has been shortened and can be seen here. To provide a systematic approach to our senior project, the DMAIC methodology was chosen. The discipline with using DMAIC ensured that our team did not skip crucial steps when approaching our project. The tools listed here will be discussed in greater detail in the following slides.
We did literature reviews on 10 different works related to inspection security systems, queuing theory, simulation, and facility layout design. The most prominent literature review was on an article that used discrete event simulation to divide airport passengers into two categories: registered travelers or regular passengers. Then the categorical divide continued throughout the security approach. Registered travelers essentially went through an express lane that would only require checking once before cycling passengers and luggage through the system. Regular passengers queued into a slower lane that required double checking of their luggage and careful consideration towards these passengers. The mentality follows that registered travelers are given the benefit of the doubt and more trust. This idea was used heavily for our senior project and was applied as one of our solutions. Here displays a list of deliverables completed and the times that it took to complete them. The thought process for choosing these deliverables will be covered next. In order to accomplish the design of experiments, the process and constraints must first be thoroughly understood, which was previously covered by Natalie. Based off the current security process, the team came up with proposed system designs that can be implemented on the security floor. One redesign idea was to improve the current layout, including reorganization and optimization of the volume of plastic bins. The next potential solution was using existing equipment that is currently not being used, the third X-ray. This will help with accommodating more workers, which is vital during power outages when the number of workers entering the facility doubles. Some potential general recommendations to improve the security process were also devised, such as optimal noise level, standardization using standard operating procedure documents, security video design, redesign, signage redesign, reducing the number of employees required, separating lanes for permanent workers and temporary workers. Next, a verified simulation model of the current security process was created using time study data provided by the stakeholders. This model will be compared with the team's alternative model. Queuing theory was also used to check the simulation model and they were both close in values. The proposed learning curve fitting estimation experiment will be a physical representation of the metal detector, X-ray, and exit stages of the security process. The purpose of this experiment is to collect data on the learning curve of new workers that go through the metal detector process. For the learning curve fitting estimation experimentation, the team used a Cal Poly classroom and IME 223 students in order to simulate the security process. The students represented temporary workers unfamiliar with the process. The metal detector is the focus of the experiment since the learning curve predominantly occurs here. Since a real metal detector cannot be present, team members acted as a metal detector. The team pre-made numbered bags with metal and non-metal items and made a spreadsheet that lists all this information. The team members check if the student has taken out all the metal items based on this spreadsheet and notifies the student if they have forgotten something, which simulates a metal detector. They have to remove items until they have found all the metal items. For the Simio model, an alternative model with the team's proposed improvements was made. The layout and model's objects are the same as the original model, except the temporary outage workers use the two leftmost search trains, and the permanent workers use the rightmost search train. The model also incorporates an additional third lane. There were a total of 4 Simio experiments, and a confidence level of 95% was used for all these experiments. The t-distribution was used for experiments 1 and 2 because these hypotheses are differences and the standard deviation is unknown. The first experiment will compare permanent worker time and system and temporary worker time and system for 3 different distributions for inner arrival time of bins. The second experiment focuses on comparing the 4 turnstile throughputs, permanent worker time and system, and temporary worker time and system difference between the original model and real data. The third experiment focuses on comparing the 4 turnstile throughputs, permanent worker time and system, and temporary worker time and system difference between the original model and the alternative model. The last experiment compares the permanent worker time and system and temporary worker time and system difference between 3 different worker inner arrival times. The Visio model was made to scale with all the facility's machinery and equipment. The team used this tool to shift equipment to test if the new placement would improve the flow and create open space for more equipment.
From the learning curve fitting experiment, it was found that temporary workers face a learning curve at the metal detector. This supports the idea of having separate lines for permanent and temporary workers. Once the Simio model was created, it was checked for validity. Then an alternate model was created and subsequently checked. 11 tests were conducted. The first 5 tests compared the Simio model to the real data received from the stakeholders, and it was found that the model is not significantly different from the real system. That means the model is a good representation of the system. The last 6 tests compared the validated Simio model to the alternate process model. It was found that the alternate model was significantly different from the validated model. Therefore, the alternate model is faster and allows more workers through the system. Based on the previous information, it is recommended that there be 1 lane for permanent workers and 2 for temporary workers. A Kanban system utilizing standard queues and refined processes in order to reduce waste and maximize value is suggested to optimize bin replenishment. A new X-ray machine and additional conveyor belt, along with a new conveyor belt system, is advised to pass bins through the system more efficiently. Changes in the placement of security officers is advocated to cut down on the number of officers necessary for the process. To reduce noise that interferes with communication during the process, it is recommended that noise controlling panels be installed on the ceiling of the security building. Signage to guide and advise workers is essential to improving the process. Standard operating procedures were created for the security officers and workers, so the process will be consistent and allow for ease in changing procedures if necessary. An instructional video was made to facilitate the education of temporary workers, so they are better prepared when they go through the process the first time. The benefits created by reducing the number of officers needed for the process outweigh the costs of the new equipment and the costs of the other recommendations. The overall savings is more than $400,000, and a more detailed breakdown of the costs and savings can be found in the full report. Of the recommendations, only the new conveyor belt system is not feasible because it is impractical as there are security restrictions that would not allow for the new system to achieve its fullest potential. Implementing the recommendations results in a savings of 490 hours for workers passing through the system, which is approximately $27,000 in worker costs.